All right. Um, um,
So,
yes,
can I ask a question? So,
absolutely. Yeah, go ahead.
in the previous slide, it says that the implicit function theorem gives the law of demand. So,
All right.
can you please tell like how does the implicit function theorem gives the law of demand?
I will make that clearer later, right? So we'll talk full, in full glory about the implicit function theorem. Let me just say the following. Uh, the main thing is mathematically, um, yeah, I haven't even quite stated what the implicit function theorem is, right? So I'm kind of planting a flag there in some sense. Uh, so what is this implicit function business? See, the first order condition of the consumer's optimization problem gives you the demand function in implicit form, not in explicit form, right? The explicit form of the demand function will have qi on the left hand side, and everything else on the right hand side will be a function of prices and other stuff, right? That's not the form in which the function presence is present over here, right? It's mixed up, but in principle, from this equation, we can derive the explicit demand function. I showed you with a simple example of log utility. There, we can rearrange terms so that, qi goes to the left-hand side and everything else goes to the right-hand side. Yeah. But often, we don't even know what the functional form of the utility function is, right? So the demand function remains implicit uh, in an equation like this. It's not an explicit solution, it's an implicit solution for the consumer's optimal choice. Now, starting from that point, often we are interested in questions of comparative statics, meaning if some of the parameters of the problem change, how does the optimum choice or the demand of the consumer change, right? So we are interested in questions like that. So, uh, so often we don't necessarily want to find an explicit solution for the demand function, but without having that explicit solution, we want to answer questions like, will the consumer buy more or less if the price of the good goes up? We want to, so those kinds of exercises are called comparative statics exercises. So that's the exercise we are doing here. When we are investigating the slope of the demand function, we're exactly engaged in a comparative statics exercise. How does optimal QI respond to changes in prices? Okay. And we are trying to answer that question, right? What is the slope of the demand curve? How do consumers respond to price changes? We are trying to answer that comparative statics question starting from an implicit form of the demand function, not an explicit form, right? Starting from uh, this equation, which is the demand function in implicit form. So that's why we use this implicit function theorem. And what is the implicit function theorem? Well, I won't state it in full generality right now, but the logic that we use, converting it to an identity and then equating the derivatives, that is the spirit or the flavor of the implicit function theorem. I'll you know, uh, later on in a few lectures, I will tell you what the implicit function theorem is uh, more generally. Yes?
Okay, sir. Thank you.
Mm. All right. Any other questions? Okay. So,
Uh,
yes,
so how Inata condition made interior point optimum for consumers?
that's what I just answered, right? That
I
the,
was unable to listen in that time.
so the Inata conditions tell you what? That if your consumption of the good is zero, then your marginal utility is infinity. Okay. So if you're not consuming anything and you consider a little bit of extra consumption, right, uh, then you get infinite marginal utility from that, but you only pay a finite price. So you will be interested in doing that. So if you're sitting at zero, it will be optimal to move away from that and buy at least some positive amount. Similarly, if you're you know consuming uh, towards infinity, the marginal utility is zero. It approaches zero in the limit. Uh, so for high enough quantity, the marginal utility will be less than price. So if you're buying such a high quantity, you will be able to increase your overall utility by cutting down on your consumption, because the last unit you're consuming gives you less utility than it costs you, right? So,
Okay, sir.
so these two extreme derivatives make sure you will want to move away from the extremes.
Okay, sir.
Okay.
One last thing, if
Yeah.
there was something called as negative consumer surplus, like we spoke about yesterday, would
Mhm.
it be the lower part, the lower triangle in the diagram that we see?
This triangle,
Yeah, because it'll be less than price and on the demand curve, like under the demand curve, but less than price. So,
right? So, what is your question again?
no, would that be the negative surplus if there was something called as the negative surplus, consumer surplus?
Yes. Um, so, okay. Uh, let me say it in words. Pardon me for not having everything in place. I have the whiteboard, but I have a shortage of ports. So I have to get a new device so that I can operate my microphone, camera, and whiteboard at the same time. But suppose this is the price. Okay, look at this picture. This is the marginal utility curve as well as the demand curve. This is the price. Uh, this is the optimum quantity choice of the consumer, right? But suppose the consumer makes a mistake and exceeds this amount. Suppose the consumer consumes some amount which is like here, right? Then if you extend the price line, there will be a smaller triangle, right? There will be another smaller triangle cropping up over here. You have to sort of,
So you can use annotations.
I can use annotations, but really I wanted to draw the picture. Will annotations give me, oh, wow. Uh, let me see. Never used that button before. Draw, draw.
So there is an option to share screen and then you can use the whiteboard if you'd like.
No, no, I know. I have a whiteboard ready. The problem is that it requires another USB port, which I don't have at the moment, right? So I've ordered a device. Okay, so suppose the consumer exceeds and consumes this extra amount, yes, by making a mistake. All right. So let's think about what will be consumer surplus in this situation. So what is the answer? Anyone?
So the bigger triangle minus the lower triangle, the smaller one.
The
Minus the
smaller triangle above
smaller
the.
triangle. Yes. Right. And the reason is why. Let's think about the reason intuitively. Right. Up to this Q amount, you're gaining positive surplus for every additional quantity you're consuming. Right. Because the value of that extra unit is above the price line, above the price. But moment you overshoot, you go beyond Q at sort of this range of quantity, then every successive unit has a value given by the height of the demand curve, which is less than the price, right? So the gap still captures the surplus, but it's negative. It's not a gain, it's a loss for the consumer for this additional quantity from Q to Q prime. So that's why consumer surplus for this range of quantity will be the same triangle, the gap between the demand curve and the price, but it will be negative. So we have to subtract this negative amount from the larger triangle to get consumer surplus when the consumer makes some mistakes and consumes too much, right? A rational consumer will not do that. So if we have faith in the consumer, we'll say, okay, she'll make the optimal choice, and this is the consumer surplus she'll end up with.
Okay, got it. So thank you.
Yeah. Right. So now let's move. Okay, before we move ahead, let's talk about aggregation. Now, how do I remove this?
So there must be
There is eraser.
Eraser there. Oh. Eraser. Okay. Am I going to erase the other stuff too? Oh, gone. Wonderful. Okay. Um, right. So ultimately, we're interested in the market. We are not interested in one particular consumer, right? We are analyzing the market as a whole, which consists of thousands, perhaps, of buyers and sellers. By the way, in this whole analysis, we are making an assumption that the consumer that we just studied takes the market price as given, right, and assumes that she can buy any amount she pleases at that market price, right? If she increases her consumption, it will now have no impact on the market price. For example, it won't drive up the market price, right? That assumption was built in. The spirit of that assumption is that the consumer is too small in this market. Her own purchase decisions are a drop in the ocean, so it will not end up affecting the market price. So that assumption is the assumption of price-taking behavior, right? And the kind of market in which that assumption is reasonable is what may be called the perfectly competitive market, right? So a perfectly competitive market is a market where both buyers and sellers are price takers. All of them assume that their own individual quantity choices, buying and selling decisions, will not have a feedback effect on the market price, right? So right now we are building a model which assumes perfectly competitive markets. Later on, we'll study other market structures where that assumption will be dropped. Okay, so the market demand function is just the sum of the individual demand functions, right? Simple. Each consumer has some demand function. If we assume diminishing marginal utility, these individual demand functions will be downward sloping with respect to price. So the overall market demand function will also be downward sloping. Yeah. Now, for many purposes, it is useful to know, not only have an idea of the direction in which consumer choices shift if prices go up or down, but also some quantitative idea, right? By how much, okay? So if there's a 10% drop in prices, the law of demand tells us that consumers will buy more, but we want to have a quantitative sense of how much more, right? How responsive are consumers to price changes, increases or decreases? Now, what would be a good measure of that? One measure which jumps out right at the outset is the slope of the demand curve, maybe, right? Just dq dp, right? If we take the derivative, that tells us how much. The problem with the slope is that it's unit dependent, right? So if I'm looking at the consumer responsiveness to the price of milk, then the value of the slope, the dq/dp thing, will depend on whether we are measuring milk in milliliters or liters or gallons. Yes, and we don't want that. We want a measure, a number, which is unit independent, because that's much more stable. That's something that is easier to interpret, that that doesn't move around as we change the choice of units. Now, so that's where the concept of elasticity comes in. So price elasticity of demand is, this is the definition. So think of it this way, right? I've written it in a particular form. Think of it as dq divided by q in the numerator and dp divided by p in the denominator. Yes. So dq divided by q in some sense is fractional change in quantity purchased, and dP divided by P is fractional change in the price, right? So this ratio tells us that, for example, if there's a 1% increase in price, by what percent will quantity go down, right? That's what the elasticity measure is capturing. We have put a negative sign here because due to the law of demand, one of these two things will be negative and the other positive, right? If there's a price increase, quantity will decrease and vice versa. So in order to not report negative numbers, we can put a minus sign in the definition itself so that the final calculation will come out to be positive. Okay, so if we have a low value of this elasticity, what does that mean? That means that consumers do not respond too much to price changes, right? Their responses are sluggish. So if there's a 10% price change, maybe they'll change their demand by 1 or 2% if the elasticity number is low. And if the elasticity number is high, that means that they're very, very price sensitive. High elasticity means consumers are price sensitive, that even a small increase in price leads to a lot of consumer flight, right? They cut back on buying by a big amount. The value of the elasticity will, of course, depend on the nature of the commodity. Yeah. So, for example, if we are looking at apples, it's very likely that apples will have a high price elasticity because it's only one fruit, right? There are many other fruits which are close substitutes. You can buy guavas, you can buy bananas, and so on. So consumers are very likely to switch if apples suddenly become very expensive and other fruit prices don't change, right? On the other hand, if we are talking of petrol, for example, or short-term housing market, for example, yes, there consumers have very few alternatives, right? It's first of all something which you cannot avoid. If you have a car, you have to fill it up with petrol. If you have driving needs, you have to find a place to stay. So these are kind of necessities with very few substitutes. So you can expect for these commodities price elasticity to be very low. It will tend towards inelastic demand, right? Now, everything is contextual. So if you're thinking of price elasticity for petrol over the next week, right? If petrol prices suddenly go up 20% today, people will find it very difficult to cut down on their consumption in the next week or two. But give it enough time, right? Opportunities will arise. You can, for example, sell your bigger car and get a smaller car, more fuel efficient car. You can start carpooling. You can sell off your car and start taking private transportation, right? So substitution possibilities will be bigger as time passes. So that says that price elasticity itself may change depending on the time horizon that we are talking about, right? But having said all of that, this measure of elasticity is very useful as a measure of the strength of the response coming from consumers to price changes. Yes, and having defined price elasticity, I can go on and define other kinds of elasticities. For example, I may be interested in knowing how responsive are consumers to income changes, right? So right now we are in a situation where GDP is going down. There has been, in the last several quarters, I mean, we have had unprecedented drop in GDP. So people are losing incomes, right? What kind of commodities, in which kind of markets will that have a bigger impact, and where will the impact be smaller? So part of that, to answer questions like that, we need to know the income elasticity of various goods, right? So we can take the same definition and substitute the price by income, and that will give us the formula for income elasticity. So once again, it's the ratio of percentage change in demand divided by percentage change in income, which triggered that change in demand. Um, so, and so on. You can talk about cross-price elasticities, right? What happens to the sale of cars if the price of petrol changes? What happens to the sale of tea if the price of if coffee becomes more expensive, and so on. So there we will substitute the goods' own price by the price of some other goods to get what is called the cross-price elasticity. Okay, so we have just defined elasticity. We'll see its use as we go along, right? But it's a very important concept for many purposes. All right, let me switch to the other side of the market, which is firms who are producing and selling the good that we're talking about, right? So if it's wheat, we're talking of farmers. They are the sellers. Okay, so there are M firms in this market, let's assume. They're indexed by J. J goes from 1 to M. Firms, of course, have costs of production, right? What are we going to assume about the objective of the firms? Well, the standard starting assumption is that firms are profit maximizers, right? They're in the market to make as much profit as possible. Now, of course, that doesn't apply to all the firms. In India, we have public sector enterprises, for example, right? Um, uh, Indian Railways, various other companies which are owned by the government or government has majority stake, Air India, and so on. Now, those don't necessarily pursue a pure profit motive, right? But it's not a bad starting assumption that most private firms, you can also think of private firms which are not profit maximizers either, right? You can think of NGOs, for example, Oxfam, right? Oxfam is not trying to maximize profit, it has social objectives. But for now, we'll keep those aside, right? We'll focus on profit maximizing firms and follow the implications of that assumption. Okay, so profits are the difference between revenue and costs, right? But let's think of or make a distinction between three kinds of costs, which will be useful. First, there's sunk costs, right? Sunk costs, and this is represented by SJ. Sunk costs are costs which cannot be recovered even if the firm shuts down and goes out of business and quits this market, right? Even then, these costs cannot be recovered. Compared to sunk costs, there are fixed costs, FJ. These costs are avoidable, but they're independent of quantity. As long as the firm is there a question, guys? Does anybody have a question?
Sir,
Yes.
sir, a part of sunk cost would also be a fixed cost, right?
I'm coming to it. I'm coming to it. Let me
Okay, sir.
give me a couple of minutes, and I hear voices. Not all of you are muted. Could you, if you have a question, please ask. Otherwise, please make sure that you're muted. Okay, guys, please make sure you're
Abhimanyu, mute yourself, bro.
Anirudh, please mute yourself.
No, sir. Abhimanyu has his voice on.
Abhimanyu.
Yeah.
Abhimanyu, please mute your microphone if you're not asking a question. Okay. Okay. So, guys, there's, let me just say that there's more than 200 people in the class, right? So be very vigilant about managing your microphone, please. If even one or two mics are on, that creates a lot of background noise, right? So, as I said, always feel free to unmute yourself if you have a question to ask, but at all other times, please make sure that your microphone is off. Yeah, uh, I need your cooperation on that. Okay, so let me give you definition, then examples, and then we'll talk. Yeah, then I'll take questions on this. So sunk costs, fixed costs. Fixed costs are costs which can be the firm can get rid of those costs if it literally folds up and goes out of business. Then it doesn't have to pay the fixed costs. But as long as it's there and producing and participating in the market, it has to bear the fixed costs. The thing about fixed costs is that it's independent of the quantity that the firm is selling, right? And finally, there's variable costs. And variable costs rise with the quantity that the firm wants to manufacture. Okay, so let's talk of an example. Suppose there's a dentist, right? And the dentist is in the business of, offering dental services. So the dentist has hired some premises where he has opened his chamber, right? Now, one kind of cost for the dentist is the cost of medical school. The dentist went and studied for 4 or 5 years, got a medical degree, and that was costly. Yeah, but suppose the dentist is thinking of, giving up dentistry. He's bored. He doesn't like it anymore. He wants to uh, uh, go to Bollywood and try to be a film star, let's say. Yeah. So if he makes the switch, if he leaves dentistry, uh, the cost of his medical education won't come back. That is water under the bridge, right? So that is a sunk cost as far as the dentist is concerned in our example. What is an example of fixed cost? Well, the dentist is, running this right now, even while he's contemplating his decision whether to try to go to Bombay and join the film industry. He's running his chamber in somewhere, right? In house curse. So there's a monthly rent he has to pay for his office premises, for his chamber. Uh, and that rent has to be paid whether there are, 10 patients per day or whether there are 100 patients per day. Right? It's independent of how many patients he's saying. It's just the rental for the premises. So that's an example of a fixed cost. If he folds up and goes to Bombay, he can avoid this cost. He no longer has to pay the rent, right? He just won't renew the contract. So unlike the cost of medical education, this is a cost which is avoidable if he folds up altogether. But it's a cost which is independent of volume or quantity or the number of patients that he's serving. And finally, there's variable costs, right? So every patient who has to be attended to, he has to hire, personnel, sort of secretaries. There has to be, if he wants to serve more patients, he has to perhaps buy more equipment, more chairs, and so on. So those contribute to variable cost, right? So that's the distinction. Yes. Now, nothing is written in stone. In our example, the dentist has already completed his education and acquired his degree. But if you review his economic problem at another point, so suppose there's a student who has just gotten admission to a dentistry program after, class 12 exams. And that student is deciding whether I should get into dentistry, do this course, get my degree, or whether I want to try my hand at acting, right? So if somebody is making a decision much earlier in life before acquiring the education, then the cost of education is not a sunk cost anymore. Then it's a cost that you can avoid by choosing not to go to dental school, right? So everything is context dependent, yeah? But if you go back to my earlier example where the dentist is, out of school already and has acquired the degree already, at that point, the cost of education is a sunk cost. Okay, so somebody had a question. Right? This is the right time to ask the question. Anybody? So somebody was asking a question about
Uh,
Sunk versus fixed cost.
yes, sir.
Yes, Kadika. Yeah, go ahead.
Sunk cost a part of fixed cost or the fixed cost a part of sunk cost?
They are different costs. Once the situation is concretely described, every cost item will, um, fall into one of the three categories, right? So something which is a sunk cost, or let me define it that way at least, right? Uh, a some something is a sunk cost if it's absolutely unavoidable, if it cannot be recovered, right? But if something can be recovered, but it's a cost which is independent of volume or quantity, then we'll call it a sunk cost. So we are defining it in a way so that they are mutually exclusive items, right?
Okay, sir. Thank you.
Yeah,
So if someone is deciding to go to Bollywood before joining the medical school, then it's the fixed cost,
that's
the
right.
expenses of education.
That's right.
Okay.
Yes. So whether something is a fixed cost or a sunk cost or a variable cost will very much depend on the context, the story, the situation that we are examining, right? So you shouldn't think that cost of medical education is always a sunk cost. No, it depends on at what point of life the agent is making that decision.
So,
Yes,
so suppose that you gave the example of rent in case of fixed cost. So suppose I start a firm and I pay the rent for suppose 1 year, right? And after that I decide that I want to close my firm. So the rent that I paid for 1 year, that won't that be sunk cost because I cannot recover that cost.
absolutely. Yes. So once again, as I said, everything is contextual, right? The rent that you have paid in the past, you won't get back. Yes.
Yes.
So take the example, you bought an airway, an air ticket, right? You were planning a trip and you bought a ticket, and now some difficulty has come up. Yes. So you're thinking of whether you should cancel the ticket, right? Now, typically, what happens is that they give you partial refund. Yes. So suppose the ticket cost 7,000 rupees and you look up the rules and it says that, well, cancellation fee is 3,000 rupees. Okay. So now when you're deciding whether you should stick to your travel plans or whether you should cancel the ticket and do the alternative, uh, the opportunity cost of the ticket is 4,000, right? The 3,000 part is sunk cost.
Yes.
3,000 out of the 7,000 that you paid. But the remaining 4,000 is not a sunk cost because you can get it back.
Okay, sir.
Yeah.
Thank you.
So you have to look at the devil is in the details. Yeah, you have to look at the specifics of the situation. All right. Now, uh, this is the variable cost function. So we'll, like with the consumer part, we'll make some assumptions. We'll assume that the first derivative is strictly positive and the second derivative is also strictly positive. So the first derivative captures the marginal cost. What is the extra cost if the firm wants to produce a little bit more? And the second derivative is how that marginal cost changes as the firm is scaling up its production. So this is really an assumption which says increasing marginal cost, that it becomes increasingly more costly to add to output a little bit. Okay, is that a reasonable assumption? Well, we'll study the theory of the firm and costs and so on in detail later, but I think one can make some appeal to intuition that in many situations this may be true. Okay.
Hello.
Yes,
Sir, my
Akanksha.
question is
Hmm.
yes, my question is that when if we are calculating a profit
Hmm.
for a firm, so should we include sunk cost as a part of fixed cost in that profit?
Yes, I got distracted. Why am I making this distinction? Well, some costs are irrelevant for decision making. It's something that you will never get back, right? So a rational firm, a rational agent will ignore sunk costs, okay? Uh,
Okay.
so when they maximize profits, revenue minus costs, sunk costs shouldn't be included in uh,
Okay.
in in the cost item. Yes.
Okay.
Uh,
So I have I also had a doubt.
yeah.
Can I ask regarding
Yeah.
sunk cost?
Right.
So if government announced a lockdown of
Yeah.
for 20 days and
Uh-huh.
should it continue for further 20 days, so will it take into account or will it say that it's sunk cost therefore in number of days?
Well, if we have already spent, let's say, 2 months in lockdown, and that has caused a lot of income losses, what have you, then those losses are at this point sunk cost, right? The past lockdowns and the losses arising from that are sunk costs. We won't be getting it back. But when we are, or the government is contemplating future lockdowns, then the cost of that is not sunk, right? That's something which is avoidable by not having the lockdowns.
Okay, got that.
Yeah. Yes, but I mean, it's
Hello, sir.
just a second. Let me just complete that answer. So, but of course, in your example of lockdowns, uh, yes, the losses are sunk, right? But policymakers have to be aware that something that was done in the past has had certain consequences, right? So, for example, um, some groups of people may have suffered huge losses. For example, small businesses, right? This has been a big part of the discussion that due to the lockdowns, the MSMEs, the micro, small, and medium enterprises who don't have deep pockets, right? Who uh, are not financially resilient, they took in losses for several months, and that may have taken many of them on the brink of bankruptcy, right? And unless they got some relief, some assistance, many of them could go out of business. So, so yes, the losses that were suffered are sunk, right? But that may have changed the situation of many firms. And so policymakers cannot, so saying all the losses are sunk is not to say that policymakers shouldn't pay attention to the damage that was created by the lockdowns on certain sectors, certain kinds of firms, and so on, right? There are various entities that need to be rescued because of what happened in the past. And unless the relief comes, um, they may go under the bus, right? So sunk costs doesn't mean we have to erase them from our memory. These are costs we won't get back, but there may be associated things that we can do to change the situation of the relevant agents. Yes, go ahead. There was a question?
Sir,
Yeah. Sushant, yeah.
sir, my question about the marginal cost.
Yeah.
So, let's say if I own a firm and I have till now produced 10 units of goods.
Right.
So, I have now experience and smoothly running infrastructure. So, marginal cost should decrease, no?
Yes. So you can think of absolutely. Excuse me. Uh, you can think of situations where marginal cost may not be decreasing. So for now, we'll make this assumption. You will see the analytical role of this assumption in a couple of slides. Um, I'm not claiming that this is an ironclad empirical truth that firms everywhere in all situations experience increasing marginal cost. There, we can think of situations, we can find situations, we can explore it in data where this is not true. Uh, I'll talk more about that. Well, we'll get into we get into the details of the theory of the firm. We will investigate possibilities where marginal cost is going down because of things like what are called increasing returns. But let me not, uh, try to talk about everything at once. For now, it's not an outlandish assumption, right? That marginal cost may be increasing. Part of what you're saying will be captured here in this slide right away. So the total cost, the total relevant cost, right, ignoring sunk costs, the total cost will have a fixed component and a variable cost component. Now, we can define average cost as the usual way, right? Total cost divided by xj. And again, there's a typo here. This phi j should be divided by xj, right? Now, if you look at the expression for average cost, if you look at the first part, that part is declining, right? as you increase quantity, the fixed cost per unit becomes smaller, right? So that part of it, that part of average cost tends to pull down average cost as quantity increases. But the second part could be a rising component, right? Phi divided by xj would be increasing as xj goes up. Uh, so often, it the average cost functions can be U-shaped. That initially this declining part dominates the slope of the average cost function, but later on the increasing part takes over. Um, so some of the stuff which I think Sushant was having in mind, some of it, not all of it, is already captured here through the fixed component, right? If there are big initial setup or overhead costs, that gets spread out over a large number of units as the firm expands in volume, and that tends to bring down average cost, right? At least up to a point. So that phenomenon is consistent with rising marginal cost, right? You can have rising marginal cost, but falling average cost over a certain range. All right. So the first problem, let me speed up here a little bit because I want to talk about at least one example, if I have time, one application to go beyond just the math. So the firm is solving a profit maximizing problem. Profit is a function of quantity. Once again, this is a price taking firm operating in a perfectly competitive market. So price is revenue, price times quantity, minus the total cost, fixed plus variable, but not counting sunk costs. So if you maximize this function, set its first derivative equal to 0, assuming an interior solution, then you get the condition that profit maximization is achieved at a volume, at a quantity where price and marginal cost are equated, right? So just as the consumer's optimizing principle was consume up to the point where marginal utility equal to price, the firm will produce up to a point where marginal cost equal to price, right? That's the corresponding version for the firm's problem. And if we, as we should, if we are worrying about second order conditions, then the second derivative of the profit function has to be negative. And you can easily see that that means the second derivative of the cost function, and specifically the variable cost function, has to be positive. Yes. And this is where that assumption comes in, right? The assumption can be motivated on grounds of realism or but if that assumption is permissible, if we are satisfied that this assumption is reasonable for a particular industry we are studying or whatever, then that assumption will guarantee that the second order condition is satisfied. If we don't make that assumption at the outset because we are in doubt about whether it holds or not, then at the optimum point, we have to make sure that this inequality is true, right? But if you're prepared to assume that this inequality, this second derivative is strictly positive at all values of xj, then that automatically takes care of the second order condition, right? So the assumption of rising marginal cost will play two roles. It'll make sure that the second order condition is satisfied, and you'll see in a moment it will tell us something very precise about the slope of the supply curve. So just as diminishing marginal utility implied the law of demand, negatively sloped demand curves, similarly increasing marginal cost will imply positively sloped supply curves. So let's see that. Same trick as before. We will, this is an equation, but if I define xjp as a function of p as the solution to this, right? So the solution to this is if we solve for xj as a function of p so that this equation is satisfied, then that is the supply curve of the firm, right? What is the firm's profit maximizing supply at every possible market price of the good? That is the supply function, the supply curve. So if we plug in the supply function into this equation, it becomes an identity, just as before in the consumer's problem, right? And once we have an identity, we can differentiate both sides with respect to P, and that gives us an expression for the slope of the supply function, which is the reciprocal of the second derivative of the cost function. And since we assume that that is positive, overall it leads us to conclude that the supply function is positively sloped. Yes, at least in this simple kind of model. All right. So this is another example of a comparative statics exercise. Let me quickly elaborate on that a little bit. In any model, there are two kinds of variables. Yes, there are what are called endogenous variables, or variables which are determined within the model, and there are exogenous variables or parameters. These are variables whose values are given from outside the model. The model itself doesn't try to solve for those values. The model takes it as given. Okay. So in the firm's problem, this simple problem that we set up, what is the endogenous variable?
Quantity.
Quantity, right? That's what the xj or quantity, because that's what we are allowing the firm to choose. Yes. So that's endogenous. We are interested in finding precisely the value of xj that arises out of this exercise. But what is an exogenous variable or parameter?
Price.
Price. Yeah.
Price.
Because in the, yeah. So we are not
Cost.
asking various elements of cost. Yeah. So those are given from outside. Now, once again, everything is contextual, right? After this, as we go to a market model, their price will become endogenous to the model, right? Where the model is trying to develop a theory of how prices are determined in markets. But in this part of the problem, where we are focusing on the firm's profit maximization or the consumer's utility maximization, price is exogenous in this part, right? Okay, so comparative statics exercises, the general nature of them is the following. You take a model, it has some endogenous variables, and it has some exogenous variables or parameters. And any question of the sort, how do the endogenous variables change if this or that exogenous variable shifts? That question is a comparative statics question. So deriving the slope of the consumer's demand curve and here deriving the slope of the firm's supply curve are both comparative statics exercises. How does the endogenous quantity respond to the exogenous changes in the exogenous price, right? So these comparative statics exercises arise left and right as we are doing this sort of classical price theory. And as we go along, right now we have started simple, we'll develop more general or powerful techniques for answering such comparative statics questions. Right now we can coast along because the problem is very simple. It's, one variable, a simple objective function, either there's no constraint or the constraint is simple and so on. As the models get complicated, we have to use more powerful techniques. But right now, I'm trying to give you an intuitive sort of idea of what those more general techniques are going to be. Right? Okay, so this is the aggregate supply curve, capital X, right? It's a sum of the individual supply curves of the M different firms. And since each firm has a positively sloped supply curve, the market as a whole will have a positively sloped supply curve. Okay, and just as with the consumer, we developed a notion of elasticity, right? We can also do the corresponding definition of elasticity of supply. So this is an expression of the price elasticity of supply, right? If the market price changes by, let's say, 1%, by what percent will market supply change? That ratio is the price elasticity of supply. And nothing needs to be repeated. I mean, we define it and we make it unit independent for the same reason as in the case of the consumer. Okay. We also need to develop a notion of what the supplier or the seller is gaining from the transaction, from participating in the market and the exchange. Well, here, the gain is profits, revenue minus costs. And profits can also be expressed just as in the previous case. It can be expressed in the following way. Uh, this is the marginal cost curve of the firm, right? Because of the price equal to marginal cost rule, that also serves as the supply curve of the firm. Again, everything is just corresponding to what we discussed in the consumer's case. So this curve is the marginal cost curve as well as the supply curve of the firm. Okay. Uh, take any market price. This is the market price, right? Profit or producer surplus, same thing. Right? Producer surplus is just a fancy way of referring to profits. And it's the corresponding notion to consumer surplus. So that is given by the same kind of area, right? Again, the idea is the same. If you look at the first unit, when the firm sells it on the market, it brings in P amount of money, but it costs only this amount, right? The height of the marginal cost curve. As you go to second and third and fourth units, again, the vertical distance between the price line and the marginal cost curve tells you how much the firm is adding to its profits by producing that unit of the good. And so eventually the firm stops its production here where price and marginal costs are equal. And if you add up all these vertical distances, you end up with this area, the gray area. Okay. So in any market, the various participants, the buyers and the sellers, uh, we have pinned down their principle of choice. If they're utility and profit maximizers, what is the optimizing principle? The optimizing principle is consumers set marginal utility equal to price, producers set marginal cost equal to price, right? And we have also developed very precise notions of their welfare. How much are they getting from participating in this transaction, in this market, right? And those are captured by producers and consumer surplus. Now, there's a social planner, uh, and I'll come very soon to questions of welfare. Uh, what would be an ideal social objective, for example? Yeah. Um, okay. Anubhav, we are all able to see your scribbling. Let's reserve it for later. All right. Now, let me move ahead. We'll come to questions of welfare later. Now comes the central concept of the classical theory of markets. Going back to economists like Walra and Alfred Marshall and so on. So what does this theory say? This theory says that if a market is not regulated, if the government doesn't put restrictions like price controls and quantity controls and so on, then the market price tends to find a level where demand and supply are equal, where no consumers are disappointed in their buying plans and no firms are disappointed in their selling plans, right? That's the content of the theory, of the classical theory, right? Classical theory claims that prices will always adjust to such levels, market clearing levels, right? So the engine of the classical theory, if you want to sort of make predictions based on our understanding of markets given by this sort of classical economics, then this is the engine, the notion that prices always adjust to levels where the market clears. Okay. Now, as you go out in your second micro course, I'm sure you will come across theories where you will see that sometimes prices can get stuck, not because the government puts a price ceiling or a price floor, but for other reasons, right? There are famous papers, for example, by one by Shapiro and Stiglitz for labor markets, There's another famous paper on credit markets by Stiglitz and Andy Wise. These papers develop notions of endogenous price rigidity, that even if a market is not regulated from the outside for various reasons, prices may not adjust to market clearing levels, right? For very understandable, rational reasons. I'm not going to talk about those, right? I just want to point that there is content to this idea that prices will always adjust, right? And there are theories within economic theory which says that certain markets may not clear for basically the reasons have to do with information asymmetry, right? In this course, it's not my mandate to talk about those things, but just keep in mind that uh, that sometimes markets may not clear, and we can find good theoretical reasons why that may not happen. Having said that, let me come back to track and take the sort of classical path and say, okay, for our purposes right now, we'll assume market clearance, right? We'll stick to classical assumptions. So what does that mean? That means that the market will reach an equilibrium. What is an equilibrium? An equilibrium is this vector with stars, right? There's a price, there's a quantity, and um, there's a there's a vector of quantities coming from the consumers. There's a vector of quantities coming from the firms. Capital Q, capital X represent vectors, right? So if I open it up, Q star basically is Q1 star, Q2 star, up to Qn star. It's a n-dimensional vector capturing the quantities purchased by the n different consumers. Similarly, X star is an m-dimensional vector where one quantity for each firm. So what is a market equilibrium? It's a price and two of these quantity vectors, demand vectors and supply vectors, which have the following property, that at this price, the demands of the consumers are precisely these quantities, and moreover, and the supplies of the firms are these quantities, right? Moreover, the sum of the demands equals the sum of the supplies, right? So aggregate market demand equals aggregate market supply. So the notion of equilibrium is involves the search for a price where this equality happens. Yeah. Okay. Now, let me speed up a little. When we are studying market equilibrium, several kinds of questions arise, right? Theoretical questions. One is a question of existence. What assumptions do we need to make in a general model to make sure that there is at least one market equilibrium? Because if that's our predictive notion and our model doesn't have a market equilibrium, then we are sort of rudderless, right? We are not able to predict anything about the market based on our theory. There's questions of uniqueness, right? So can the demand and supply curves intersect multiple times? Can we make some assumptions to make sure that that doesn't happen? Then there's notions of stability, that the model we are studying is a static model, right? The assumption is that there may be a period of adjustment, but eventually prices adjust to this level. There are dynamic models where the prices may start off at a level where demand supply has a mismatch, right? And the models specify how the price is adjusted if there's a demand supply mismatch, if there's an excess demand or an excess supply. Yeah. And the stability question is the question that, well, given the adjustment process, will the price eventually gravitate or find its way towards a market clearing level, right? So these are the sort of theoretical questions. Let me move beyond them, just having mentioned them.
Sir,
Yes.
sir, actually, I have a doubt. Sir, what can you please repeat the difference between X and Q in the previous slide?
I'm referring to the quantities supplied by the firms by X and the quantity is demanded by the consumers by Q, right?
Okay,
So,
sir.
so Xj is firm J's supply, Qi is consumer I's demand, capital Q is the sum of all the consumer demands, capital X is the sum of all the supplies coming from the firms. So
Okay, sir.
equilibrium involves aggregate demand, the sum of demands equaling the sum of supplies.
Uh, yeah, okay, sir.
Yeah.
Sir,
Yeah.
so do we have the scope of going deep into imaginary auctioneer? I mean, it's something out of the blue.
Yeah. Let me.
You can continue. We will, if there's a
Yes.
time shortage.
Till what time is the class? 12:55, is it?
I think you have passed.
Yes,
Uh,
sir.
Yes,
yeah.
sir.
Okay. But it's your lunch break, right? You don't have a lecture.
Yes, sir.
Okay. So give me just a minute to wrap up. I was hoping to cover this, which is comparative statics. Let me just mention, but I'll take it up next lecture. But let me just address the question, which who asked? Shubham?
Not Piyush.
Piyush asked. Okay. So the next thing that I'm going to do is use this fundamental notion of a market equilibrium and do comparative statics exercises, right? So, for example, what happens if there's a demand or a supply shock? So, for example, right now, due to the pandemic, uh, people are wary of consuming things which involve crowds, like going to the movies, for example, or eating out in restaurants, right? That involves the risk. So you could think of that as a demand shock for these goods and services. That even for the same price, consumers are more unwilling than pre-pandemic situations. They're less eager to watch movies or eat out in restaurants, right? So what can we expect that to do to the market price for these goods and services? Alternatively, you can think of some supply shock. So, for example, there's a um, some input has become more expensive. So oil prices have gone up, right? So eh, industries which are more energy intensive, like transportation, uh, they get a cost shock. So a lot of questions are, some sort of demand or supply shock coming into a market. And we as economists want to sort of analyze the situation and make prediction about what this will do to market prices, to volume of trade, and so on and so forth. Now, we can analyze that with the help of diagrams, right? Equilibrium happens where demand and supply curves intersect, and we can move around demand and supply curves. But the more complicated the situation, if we are talking of multiple markets and a set of prices, a vector of prices which clears those markets, and so on, there we cannot wrap our heads around the question by just drawing pictures. Right? So that's where we have to employ more powerful mathematical techniques, which will allow us to address these questions in more complex models and situations, right? So that's what I'm going to show you, right? How to analyze the impact of demand and supply shocks like this, and how to do it mathematically, and then relate it to the kind of simple pictures that you're familiar with. But I will not be able to get into that for lack of time. Let me come back to the question which Piyush asked, and having answered that, I'll end today's lecture. If you look closely, and I'm sure more than 90% of you, this notion of a market equilibrium is something that you're probably yawning, right? You've seen it. If you did an economics undergraduate, you've been taught, your teachers have been talking about it for the last 3 years. It's a tricky notion, yes, if you don't think very deeply. Is there any reason for us to believe that in any market prices will always find such a level? Why should we believe that, right? Some markets have explicit market makers. So if you look at some stock markets, for example, the NASDAQ or the New York Stock Exchange, you'll find market makers. You'll find some combination of some human agents and computer algorithms, which are constantly gathering, hypothetical demands and supplies from the market participants and trying to determine a price, engaging in price discovery. Their objective is to make the market to clear. But this is a feature of very few markets, right? In most markets, if you go to the bazaar, you go to the mandi, you go to, um, if you're trying to hail a taxi or an auto rickshaw, that's not an organized market. It doesn't have any market maker. So the market price evolves out of some complex process where maybe buyers and sellers bargain with each other bilaterally. Um, you know, in re- in retail markets, there's more haggling. In wholesale markets, sometimes you have auctions, right? If you go to the mandi, you have these auctions of vegetables and fruits and so on. So more modern theories, more contemporary theories sort of, instead of, this simple fiction that price will always adjust to a level where the market clears, they model the price formation process using bargaining theory, using auction theory. They model it in whichever way they deem fit, right? And then they ask the question that, if the price is formed in a particular way, ultimately, are the outcomes similar to what you get in these simple classical models, right? So we can dig much deeper. At this point, we won't do it, right? But there's lots of resources and ideas in microeconomics which doesn't take this as the stopping point, right? Where the price formation itself is part of the modeling and part of the investigation. Yes.
Sir, I have a small question before we end the lecture. Sir,
Right.
given the slopes that we have taken for our particular example, uh, I would understand that there would be no more than one equilibrium, but in general, in theory, do we have problems
Yes.
that there could exist more than one equilibrium depending on the initial state of the system?
Yeah. If you don't make any further restrictions, if you keep it very, very general, um, then you may have multiple intersections and multiple equilibrium points, right? So the question of uniqueness often involves uh, the following question that, what are the necessary and or sufficient conditions or assumptions that we need to make sure that the market equilibrium is unique? You don't get it for free. You have to put some assumptions, some restrictions, right? Um, so yeah, very generally speaking, uniqueness is not guaranteed. There are some markets in which um, either demand or supply curves may bend backwards. Yes, we'll talk about that as we go along. But labor markets can have what is called backward bending supply curves, right? That as wage rates go up, supply maybe initially goes up, but for very high wage rates, further increases may lead people to decrease the supply of labor rather than increase it, for reasons which we'll discuss later, right? And a lot of you maybe have some idea about it, income and substitution effects, whatever. So if you have backward bending, if you have downward sloping demand curves, but the supply curve is not necessarily always increasing, if it bends backwards, then you can have multiple intersections. Yes. In
Cobweb model can cobweb model.
Yeah, cobweb model refers to dynamics and stability and so on, right? So that's a model which relates to the other question, which is of stability. But yes, in general, you can have multiple intersections, right? In this simple model, where we are making very special, when we are being very bold and making very special assumptions, that won't happen because demand curves are strictly downward sloping, supply curves are strictly increasing. But if you relax the assumptions and take it to more general context, yeah, uniqueness may break down.
Sir?
Yes.
Got it. Thank you, sir.
Sir, the existence condition says that the market equilibrium exists if quantity demanded at zero price is greater than quantity supplied at zero price. Sir, how does that imply that the equilibrium?
Basically, in this, again, this simple setup, what you need is the intercept of the demand curve on the vertical axis, the price axis, should be greater than the intercept of the supply curve.
Yes, sir, but how does that imply existence? I understood this, but how does that imply existence of an equilibrium?
Um, because um then the demand curve will slope downwards and the supply curve will slope upwards. You actually need conditions on both sides, right? So you need that the demand curve starts above and the supply curve starts below. But as you go to very high quantity levels, you need that is flipped, right? The supply curve is above and the demand curve is below. So if those two end conditions are satisfied, that means somewhere in the middle there will be an intersection by the what is called the intermediate value theorem. Yes.
Yes, sir.
So let's, yeah.
So, but over here it's Q of zero. That means Q at price zero, right?
Right. So there are a few typos which I'll sort out. Right. I described in words what we need to assume. This is not written properly. I'll rewrite it.
Okay, so we're looking at inverse demand function.
That's right. That's right.
Okay.
Yeah. Any other questions?
Can I? Okay.
Yeah.
So it's about the profit maximization equation. So
Mhm.
instead of maximizing it subjected to the quantity, why don't we use the implicit function of the demand curve and maximize it with respect to price? Would it change the answer?
It will change the answer. It's a very different model. In fact, if you go back to the early history of economic thought and the way pre-20th century economists approach the problem, Leon Walra thought of, developed theories of markets where the agents take prices as given. That's kind of sacrosanct, beyond their control. They can choose quantities. Uh, there were alternative approaches. I think it was Stanley Jevons, if I'm not mistaken, but I need to check on that. There are other economists who modeled it very differently. Yes, who conceived of markets as places where quantities are given to the agents from outside. They choose their prices, right? Everybody chooses an individual price and so on. The approach where agents choose quantities and take the prices as given, that approach became popular, right? So what we do today derives from Walra and others who modeled quantity as the choice variable of agents. But there were other traditions where it was different. In fact, if you look at the standard diagrams that we draw in economics, right? Quantity is put on the horizontal axis and price is on the vertical axis. Now, normally, how do we draw diagrams? We take the independent variable on the x-axis and we put the dependent variable on the y-axis, right? If you're plotting how crop yields are a function of rainfall, rainfall goes into the horizontal axis. And the thing which depends on rainfall, namely crop output, that goes on the vertical axis. But the pictures that we draw in economics does not conform to this convention, right? Although our mathematical model says that the agents choose quantities, looking at prices, we should have put price on the horizontal axis, but we put it on the vertical axis. That's how we draw the pictures. So there seems to be a mismatch between our pictures and our mathematical models. Now, why is that? The reason that is so is that the guys who are modeling it the other way, yes, Jevons and all, who who conceived of economic agents as choosing prices given fixed quantities or orders. They drew a lot of pictures. So the pictures came from their books, right? But the mathematical models came from Walra and others who modeled it as agents choosing quantities, not prices. So it became a peculiar khichdi of two approaches. That's why you see this kind of strange disjunction between the kind of pictures that we draw and the kind of models that we write down. Would it make a difference in terms of implications if we modeled it the other way? Yes, in general it would. When you study game theory and study models of oligopoly, I'm sure you've seen there's models of price competition, Bertrand models, and there's models of quantity competition, Cournot models. And those models can give very different conclusions. So yes, it matters. It's a very good question. It matters. But for better or for worse, we have adopted the tradition where quantity is thought of as what agents are choosing.
So in the real world, wouldn't it be the other way around? I mean, the prices would be chosen while quantity should be, demanded from the outside. So that should be explicit.
It's certainly an arguable point. There are lots and lots of, it's an excellent question, but I won't be able to do justice to your question in a few minutes. Hopefully, keep the question in your brain. It's an excellent question that, um, are agents choosing prices? Are they choosing quantities? Does it matter? Which is relevant? Which is realistic? Which corresponds more closely to the real world? There are cases to be made on both sides, right? I don't think there's a pat answer. I can look at, if I go to the market and various markets and observe literally what people are doing, I'll sometimes see that they're haggling about prices. I'll sometimes get some feedback, some data which would suggest, oh, maybe the quantity choice approach seems more relevant here. Now, when you study oligopoly models, you will see that if you expand the price-based models and the quantity-based models, Bertrand and Cournot, in certain ways, if you enrich both models, then the stark differences between them start disappearing. Yes. Uh, uh, there's a famous paper by Krebs and Schenkman who show that uh, when uh, when agents engage in price competition, but they're capacity constrained, right? How much they can produce. They converge towards quantity competition. I don't want to dump a whole lot of information, right? It's a tricky, difficult, interesting, fascinating question. Hopefully, as you go through this course, as you go through the next micro course, as you study some other optional courses, you will find better and better answers to this question.
Okay, thank you, sir.
Yeah.
So, for existence of market equilibrium, do we assume that the demand curve is downward sloping and supply curve is upward sloping, along with the assumption that the intercept of demand curve is greater than the intercept of supply curve?
Yes, I'm just merely making the logical point that some assumptions will be necessary. Otherwise, there's no guarantee that a market equilibrium will exist. Even in this simple model, I can easily construct an example where demand supply curves don't intersect. Uh, so, so the existence will require us to make some assumptions.
So can I ask one
Yeah,
question?
yeah.
So behind these notations, mathematical notations and these equations, there's a message that markets are very efficient and can solve the problem of scarcity. Is there? Can you tell with your experience, do they really solve?
I haven't said so yet.
But
I mean, I
it
kind of
says the,
hinted.
but it can be seen that demand is equal to supply due to the free
Okay,
market.
there there are um, uh, do markets produce good outcomes? Right? That's in some sense the broad question. That will of course depend on what we mean by good outcomes. Now, if you think the only desirable property of an economic system is that there's no shortages or there's no glut, that unsold goods are not piling up, or consumers are not having to go home disappointed that they didn't get the things that they wanted to have. That if you think that is the be all and end all of economic life, then yes, then this model assumes off the bat that that is what happens in the market. It doesn't even prove that, it assumes that. Yes. But why should that be the only objective of society? Market clearance is one virtue, right? There are many other objectives, right? There's no reason to claim right here that market clearance is the only objective of an economic system or an ideal society, right? Are the sick getting treated properly? Are the people getting fed? There are all kinds of other. You can have a situation where the market clears, right? But a lot of people are dying for lack of healthcare. People are unhappy. They're lying for lack of healthcare because they can't afford it, not because their demand has been unmet, but at the price that the market charges, they're not able to afford healthcare. So yes, this model kind of almost assumes that market outcomes are good only if you conceive the objective of a market or an economic system is only to clear the market. But there's no reason to assume so. Okay, so very soon, with this very simple model, we'll get into the question of welfare. What does it mean to say that a market system or any other system has achieved a good outcome? At this point, I haven't started that discussion.
Thanks for answering.
Yeah.
Sir, can you once again explain how means producer surplus and profits are equal?
They're equal by definition. Producer surplus is defined as revenue minus cost. And that is exactly profit. They're just two different terms. The term producer surplus we are creating because for consumers we coined the term consumer surplus. So to sort of rhyme or match with that, we are sometimes calling profits as producer surplus. It's just a word.
But will it be the same when cost also include fixed cost?
Yes. Yes. Yeah. That so by definition, it's revenue minus all kinds of costs. Guys, I have to go because I have another appointment right now. I will send you. Keep checking your email. Once the course website is up, which will be by the end of this week.
So can I have a small suggestion?
Very quickly, please. Yeah.
Sir, if you, for other courses, we have a shared drive where the professors can update material, share material by just dropping it into the Google folder. So if you could arrange for something like that, it would be very easy for you to share material with us, be it revised material or new material.
Things should fall into place by the end of this week, right? If the way the course website is a dynamic thing where I'll update material. So if you bookmark it, you'll always see it there. But let me see if there's a plan B or another sort of folder where you can access. Yeah.
Thank you, sir. Yeah.
Let me think about that. Okay. See you guys. I really have to go. So see you next Monday.
Okay, sir. Thank you, sir.
Yeah.
Thank you, sir.
Right. Yeah.
Bye, sir.
Right.
लीव कर नीचे से